Welcome to Study Loop.
So assume we're given this function here. I'm going to find the absolute maximum and minimum values of f. To start off by looking at the partial derivatives of this formula. So f sub x will give us 2x, the first part. The second part will disappear. Then minus 2 for minus 2x. And then the minus 4y plus 1 will both disappear. If we look at the partial derivative to y, again x squared disappears. We get 4y. Take away 4, the 4y part there, and the rest disappears. If these both equal 0, we can work out a point at which we get a critical point. So this is equal to 0 here. We get 2x equals 2, therefore x equals 1. And likewise, when this one is equal to 0 here, we get y equals 1. So we have a critical point at 1, 1. So now we know, obviously looking at our bounded values here, we have, it's a rectangle drawn 2 parts across, 3 parts up. This is our D, and it has the points on here of 2, 0, 2, 3, 3, 0, 3, sorry, 0, 3, and 0, 0. So we know our maximum and minimum point. First of all, our critical value falls within this part here, so that's good to know. Then what we'd like to do is just draw a table with x, y, and our function to find our maximum and minimum points. So if we label these here, these lines L1, L2, L3, let's call it L4. We need to start doing rounders now, kind of putting our points into this graph and seeing where the maximum and minimum points lie. So if we put these points into our graph here, so we have, obviously 0, 0. We've then got 2, 0, got 2, 3, and 0, 3. We've also got our critical point 1, 1. So we start off by working out if we had, let's take L1 here. So we know if the minimum and maximum lay along this point, that L1 goes from 0, 0 to 2, 0. So y is always 0. So if we replace that into our function to begin with, we have f of x 0. This then is equal to x squared plus 0, take 2x, take 0, plus 1. So we know this is a quadratic. This will have a U-shaped curve with the minimum point. So we can work that out by finding the first derivative of x 0, which will simply be 2x take 2. That being equal to 0 gives us our minimum point where x equals 1. So we have another point to add to our table here, which would be our 1, 0. Oops, lost for a minute there. So that will be the point 1, 0. Now put an f of 1, 0 into here. it simply works out. We can work it through as 1, 0, work out as 1 minus 2 plus 1, so that'll equal x equals 1. So that will equal 2 there. So 1, 0, we can put a point in as, 0, it'll work out to be, excuse me. And then we can also look at our 2 points where f of x0 exists. So that's f of 0, 0, and f of 2, 0. Putting both them points in, and we get 1 for function of x there, and also 1 for a function of x there. So then we simply just work down our lines on our graph. So next we have L2, so the second line on there, and that gives us a function of where x is always 2, y. So plugging that through, and we get 4 plus 2y squared, take 4, take 4y plus 1. Again, gives us that quadratic we've got to look for. So it gives us 2y squared, take 4y. Let's find the derivative of this. F of 2y gives us 4y squared. Take 4, when that's equal to 0, we get y is equal to 1. There's a new point in there of 2, 1. Go back to our chart. We've got the point 2, 1. And when we work that one through, we get equal to 1. We can then go back and look at f of 2, 1. Sorry, f of 2, 0 and 2, 3. And f of 2, 0 gives us 1. We've already got the 1. And f of 2, 3 gives us 7. Go on to L3 then, and we'll do the same thing. We get another point at 1, 3 here when we find the derivative of that, and that gives us 6. We then complete for 0, 3, and it gives us 7. So we've done that, we've got all our points. We can check on the L4 as well. We've already got our points for that. And then finally we use our critical point here. You can see is minus 2. We plug them in. So we can see now we've got a maximum point at 2 maximum points here of 7 and a minimum of minus 2.